Okay. Hello, everyone. My name is Martin Taloboy. This is our assignment for 2022. The title of our assignment is Auki Jet. Auki Jet, it was located in Malita Province, Solomon Island. We are 5 members of our group: Lincoln, David, myself, Simon, and Jerry. Introduction. Auki is located in Malita Province, Solomon Island. It is an international project which is entirely sponsored by JICA. Auki is known to be the third largest town in Solomon Island with an estimated population of 5,000 to 6,000. The title island with the name Auki is called after a small island neighboring with Langa Lagoon. On Malita east coast at the mouth of the lagoon is the village of Auki. It was chosen as the location on the island based administrative center in 1909. MV Randbell, LC Swift, Tina 1, and other small landing vessels with flaps at their bows that allows vehicle to be rolled on and off the vessel are among the vessels that use Auki jet. Such type of vessel comprise approximately 10% of registered vessel in Solomon Island. For this vessel with flaps, a slope on the jet is necessary in order to lower the flaps onto the top of the jet, because the top of the jet with a normal structure has an elevation that is too high. According to the study, the flaps harm the jet edge and the surface of the slab that weren't reinforced for car perish because the jet was operated without a slope. For this small car barriers type vessel to be able to lower and use their flaps, a very ramp is planned as part of the jet. As you can see, the three images here, this is Auki jet, including Auki town, and this image we taking from the internet. That's all from me, and I will hand over to the next person to continue with the next slide. Vinaka.
Basic plan of jetties. Overall plan. West of the current jetties is the new straight pile type jetty is constructed. The jetty structures is constructed of steel tube pile type to reduce the effect of sedimentation, and of a straight pile type taking the procurement construction machineries into consideration. In Solomon Island, there is no technical standard for construction of port structure like jetties. Hence, we design compliance with the New Zealand and Australian standard. Company design condition such as external forces, durable years, and similar a result similar to the New Zealand and Australian standard. And this jetty project is funded by Japanese, designed by the Japanese, and constructed by the Japanese. Here are some of the standard that the Japanese use to design structures like jetties, technical standards, and commentary for ports and harbors facilities in Japan, ports and harbor structure design samples, corrosion prevention of ports and harbors steel structures, standards for estimation of concrete construction port civil engineering works, BC Jetty's technical manual, jacket method technical manual, specification for highway bridge, standard specification for concrete structures, and steel pile type designs and construction. The construction sequence, site position, preliminary and general items, site clearance and revetment works, pile works, pile load test, construction of substructures, installation of precast pre-stressed beam, in situ concrete work, deck finishes, fabrication and installation of structure steelwork, navigational aids, and a handover.
Okay, this is the facility designs, sign plan, provincial government, and the individuals with the customary right to use the property have certified that there are no issues with issuing the land for this project with regard to ownership of the right to use the land and water reserves to the east and to the west of the existing jetty. The issues given particularly consideration during the site planning are as follows: removal of sunken vessel, location of the head of the jetty pile diameters, setting of the normal lines of the jetty and the vessels crossing the case of site plan 1, establishment of a safe distance between the jetty and the sunken vessel. This is the plan drawing that the standard approach angles of vessel docking at the jetty. The floor plan, the berth length, according to the basic design study report on the project for construction of Market and Jetty in Alpine Solomon Islands, online page 22242, length of vessel is 53.14 ml times 1.2 equals 64.08 to 64 meter. That's required berth length is shown here in this picture. And the width of the jetty, according to basic study report, the required width is approximately shown in this table, and specific required width is shown on the next slide. Therefore, the required width of the jetty is established as follows: established for uploading 2 meter due to efficient of cargo transport. It will have to 1 meter and 0.5 meter for car stop, so as 0.75 meter for mooring post. The minimum sidewalk width of 2 meters specified in Article 11, sidewalk of the Road Structure Ordinance, Ministry of Land, Infrastructure and Transport of Japan, will be adopted. The space for cargo handling vehicle traffic can be regarded in the same way as the harbor road. Specified the width of such roads at 3.25 meter or 3.5 meter in principle. As a result, it is considered possible to reduce the width of the planned cargo handling jetty to 6 meter per shed or 12 meter in total. Plan with composition and trucks or small record trucks with load capacity of 2 tons for turning. This is the plan view shown in the report, and this is how they show it in the plan. For the structural section planning, structural type, in general, the basic structural types of mooring facilities can be classified into 4: gravity, seat pile, and pontoon types. Reason for plan site: seabed topography and shore study favor the pile jetty type as a soft stratum of sand mixed with its silt or silt mixed with sand with the N value of 2 to 6 occupies the layer from the current seabed to 24.5. Without consideration, settlement is likely to occur with heavily structured such as gravity and seed pile type structure. A pile thrust jetty is suitable for site which is ground to soft to sustain gravity or seed pile type structure as there exists a solid limestone layer at a depth of 24.5 meters from the current seabed in the plant site. The construction of a pile type jetty with this layer as the supporting layer is considered to be the safest and best method. Pile jetty structure. The two section types of the jetty uses horizontal pile type and the vertical pile type. As the plant site is located in a small island country in the ocean, it is difficult to procure heavy machines for marine civil engineering within the country or in neighboring countries in a short time. Therefore, adoption of the vertical pile type is not favored. Thus, the vertical pile type is suitable for this plant. So this is the vertical pile type that is used in Aoki jetty. Based on the geological surface result, piles are designed as bearing piles and their foundation embedded through the solid limestone layer at a depth of 2 to 3.25 and the existing seabed until they reach the softened stratum of sand mixed with silt and silt mixed with sand, and the end value of 2.6 is existing. The total length of the pile is according to 31 meter to 39 meter, corresponding to the width depth. Examining the horizontal load as shown in the closed tree and diameter, thickness, and layout of the piles are determined to be 4 rows times 700 mm times t equals 12 mm for the main landing jetty, 3 rows times 700 mm and t equals 12 mm for the access jetty. Thank you. Hello, this is Jeremy Kelly. I'll be taking the design conditions of the jetty. This is the reference and the standard codes that they use in designing the jetty in Aoki, Malay Province. And then the planning condition and usage condition. Planning conditions include plan water depth, design water depth, planned crown height. Usage conditions include vessel using the jetty, docking speed, working lifetime and anti-corrosion measures. Working lifetime is around 50 years. Anti-corrosion measures Natural conditions is included by the sea level, and level of existing seabed. Soil conditions, reefment, BHJI, mooring and access jetties, BHJ2. The design seismic intensity, as the Solomon Islands are located on the boundary between Australia Plate and the Pacific Plate, they occasionally experience earthquake of M4 or above. According to commentaries for port and harbor facilities in Japan, 1999, the Japan Port Harbor Association, the design intensity or the design seismic intensity KH equals to 0.215 times 1.2 times 1.2. The gain was 0.22. The loading conditions, unit weight of concrete without reinforcement. The unit weight is 22.6 kilonewton meter cube. Concrete with reinforcement, 24.0 kilonewton per meter cube. Vertical load at normal times, the weight is 20 kilonewton per meter square. At time of earthquake, weight is 10 kilonewton per meter square. Moving load, vehicle load T25. These are the attractive forces of vessels. You can see in this table that is outlined here. And then these are the additional facilities. Plans for a pile type jetty require the following additional facilities: mooring post, fenders, car stops, lighting equipment for passengers both entering the port during the night. As passenger boats enter the port from late Friday night down to on Saturday every week, equipment for nighttime lighting is required on the jetty. As the minimum elements to ensure safe operation on the jetty at nighttime, approximately 1x of illuminants at the places expected to be used most by people and vehicles is set as the target. And these are the references that we've used in accordance to our research and the PPT presentation. Thank you very much.